All right, so in the previous recording, I mentioned that when you have ordinal features, this is often a time when it doesn't make sense to do dummy or one-hot encoding. So why is that? Well, let's take a look at some of the features within our AIMS data. Now we have a bunch of features that basically end with qual for quality, QC for I think quality check, or underscore condition to represent the condition of whatever item it's referring to. So these are all features centered around let's see, the quality rating for that feature, right? And all of these ratings typically look like this. If we look at a single one of these variables we'll look at the overall quality variable, and we look at the distinct values, you can see that they range from anywhere from very poor to poor. We have below average, we have average here, all the way up to excellent and very excellent. So we can see that right now, this variable is just a character string. It's not a factor, so they're not ordered in any way. But you can see that there's a natural ordering to this variable, right? Basically, everything from very poor up to very excellent. So rather than have these represented by words that represent their rating within this natural hierarchy, we could use a numeric value, right? So the lowest one is very poor. That could be a 1. Then poor could be 2. And then fair could be 3. Below average 4. And so on all the way up to very good equals 8. Excellent equals 9. And very excellent equals 10. All right, so we could actually just change these values to a numeric representation that kind of illustrates their natural hierarchy. So when we do this, there's two things to think about. One is the variable already a factor that is ordered? Okay. If it is already a factor that is ordered, then all you need to do is go ahead and apply this step ordinal score. And what that is going to do is take the value representation that level, because they are ordered already, and they'll be ordered from 1 to however many levels there are. And it's going to turn those values into that numeric representation. Now, sometimes we're going to have factors that are represented as characters and not factors. And so in that case, we have to take multiple steps. Step 1 is to convert them into a factor. And actually, we want to convert them into an ordered factor. So what we do here is, in this code here, I basically wrote out in order the levels that my feature can take on. So it goes from very poor all the way up to very excellent, right? In the order of their natural hierarchy. So now what I can do is I can apply this step string to factor. This is going to convert a character string into a factor. So I'm going to convert the overall qual feature into a factor that's going to have these levels, and I'm going to say that they are ordered. Okay. So now what that does is it converts it into an ordered factor based off of this ordering that I supplied here. And then now I can apply this step ordinal score, which is going to convert that ordered factor into a numeric representation of the factor levels. So if I wanted to look at what the result is, I can over here at the left. Don't worry about what all this code is doing. Basically what I have done here is I've taken this ordinal encoding on this feature here, this overall qual feature, and I applied it and I did some additional data wrangling stuff. And what I resulted with is the original feature values over in this column. Right, so we can see we have the average, above average, good. And then I have the numeric representation that basically this is applying. And so we can see for any of those observations that had average, then it's going to be a 5. For any of those that have good, it's going to be an 8. And if we were to look down at excellent, I believe that would be an 11. Very poor would be represented as 1, and so on. So now we have change these into a numeric value representing, the rating of the quality for that given feature.